Here's the second free response from the Newton's Laws test. Again, we'll take a quick scroll through the whole thing so you can just pause and look at the parts you're interested in. And then we'll scroll down and go through it. Read it over yourself first. If you're going to listen to me go on about how to do each part. And so the first question is, what is the acceleration of the cart? And we are given a velocity time data, and the points are on the graph already for us. And so we are asked to determine the acceleration from the graph. And so we need to do a best line fit. So we take the straight edge that was conveniently provided for us and draw a line of best fit so that about as many points are above and below the line. So you got a point for one good line. And then we need to determine the acceleration. The acceleration is the slope. And it says show all of your work on the graph and then record the result below. So what is that work? I need to show what points I picked. So I'm picking this point here, and I put the x and the y coordinates of that point there. And then I pick this point here on the line, both those points on the line. And so that's 0.4. So the acceleration is the slope, change in y over change in x. And so I got a point for using 2 points on my line to calculate the slope. And then I get another point if I was within a ½ meter per second of using the slope to get the acceleration. And so somewhere around 8.33 is what I got. Then we're asked to draw a free body diagram of the cart and the hanging mass. And so the cart has a normal force that's perpendicular to the incline, has weight that's straight down, tension parallel to the surface, so it should be perpendicular to the normal force. We also want our coordinate system, and so I'm putting x parallel to the incline as well. That's the direction of the acceleration, y perpendicular up. The free body diagram for the hanging weight, weight is down, tension is up, and it's the same tension as we have over here. We're ignoring the mass or friction in the pulley. And then I made down positive for the weight because the acceleration is down. Now, if you made up positive, you still get the points for having coordinate systems, but you're probably going to make a mistake further down. So let's move this up and clear our... And so now we want to figure out the mass of the hanging weight and the tension in the string. And so we know the acceleration, and so we can do Newton's second law for the hanging weight and the cart. And so in the x direction for the cart, I have tension in the positive x, and I have mg sine theta in the positive x. So both forces causing it to accelerate, and that equals ma. And I can solve for the tension, and I know everything here, so I don't have to do a bunch of two simultaneous equation algebra. I can just go right to it and get the tension. And then to get the mass of the hanging weights, some of the forces in the y equal ma for the hanging weight, and remember down is positive, so the weight is positive, the tension is up, so it's negative, equals ma. And I solve algebraically for the mass of the hanging weights, and I now know the tension, so I can put that over here, and I get 3.46 or somewhere close to that. And then finally, what if I added 1 kilogram of mass to the cart? Well, you can just think about what this is going to do. It is going to give me more force, but that force is the mg sine theta. It's also going to give me more mass, but the mass doesn't have a sine theta. So in this case, adding mass to the cart increases the force, but it increases the inertia even more. And so I know the acceleration is going to be less. And so I made it harder to move the system, but didn't add enough force to compensate for that. If you really want to, you can actually go through and solve for what the acceleration would be. That would not be a bad exercise to do if you're trying to really learn Newton's laws. So over here I have that solved, and it does come out to be less, but you didn't need to do that to get this point. You just needed to say it would be less and have some sort of explanation. But a lot of people said it would slow it down. We're just talking about the acceleration. And so be careful with that. Acceleration and velocity are different things. And hopefully you saw this. Always look at the axes on the graphs.